helmet on your head, and you can visit any year you choose. You could even travel into the far future.
I am very aware of the preciousness of time. Let's imagine a warp drive that somehow defeats relativity, allowing us to travel at any speed. As Einstein said, the most incomprehensible thing about the universe is that it's comprehensible. We have this one life to appreciate the grand design of the universe. There is still plenty more to find out. We are all time travelers, journeying together into the future.
When it comes to space and time, very few people come close to the legendary physicist Stephen Hawking. He was one of the most brilliant minds of our time, revolutionizing our understanding of the universe. Hawking's life's work was centered around unlocking the mysteries of space, and one of his obsessions was time travel. He theorized we could travel through time using wormholes, but admitted that we still do not have enough of an understanding of the cosmos, and at his time of death, he wasn't optimistic about our chances of achieving it. But NASA has made a strange discovery that may unlock new information the legendary British scientist could only dream of. Is NASA really working on this technology? And what does the future hold for space travel? Join us as we explain what NASA has just discovered and why Stephen Hawkins may have been right all along. When it comes to space, there's a problem with our human drive to go all the places and see all the things. A big problem, it's, well, space. It's way too big. Even traveling at the maximum speed the universe allows, it would take us years to reach our nearest neighboring star. The planet Earth isn't going to be habitable forever, and if the human race is going to survive, we'll have to pack up our things and move to another planet. Sounds easy, right? Until you realize the vastness of space and even how big our solar system is. No matter where we're going in space, we need to travel fast, and not just at the speed of light either. We're talking about ludicrous speed. Hawking's most famous work was his book, A Brief History of Time, which became a bestseller worldwide. In his book, Hawking explored the fundamental questions of the universe, such as the nature of time, the origins of the universe, and the possibility of time travel. He believed that it was possible to travel through time, but he thought that it would require a technology that was beyond our current capabilities. Hawking also believed that if time travel was possible, it would be a one-way trip, and time travel into the past was impossible because it would violate the laws of physics. But it could also raise ethical questions about changing the past and the potential consequences of altering the course of history. Consider this for a moment. Our closest neighbor, Alpha Centauri, is 4.367 light-years away. So even if we traveled in a ship at 100 light speed, it would still take you 4.367 years to get there. We could use rockets to get ourselves around in space, but the big problem with them is the amount of fuel we would need to carry to get anywhere. But even rockets have their limits, including how fast they can push a spacecraft. We're going to need something that can generate some serious thrust and be able to do so without carrying a large amount of fuel because, in space, there are no gas stations. However, a new study indicates that time travel in both ways is not only plausible but also safe. The question is whether you would do it. At its most fundamental level, time travel is all about velocity, space, and gravity. For instance, a second for a person standing on Earth will differ from a second for a person traveling close to the speed of light or in the vicinity of a black hole. According to mathematics and physics, even if we lack the technology to travel so quickly, this is how time works. We all travel in time. For example, we go 1 year forward in time between birthdays. And we all go through time at roughly the same rate, 1 second per second. Time dilation, a feature of Albert Einstein's special relativity, describes how the rate of motion modifies the relative sizes of mass, time, and space. Einstein was the first to recognize that time is not constant but rather slows down as you travel faster across space. What this means is that time is an illusion that changes depending on who is looking at it. If you could move at the speed of light, you would perceive time to pass considerably more slowly than it would for someone who remained at rest. Even astronauts in space age more slowly than those on Earth. In order to time travel, it is crucial to know how space-time functions. The concept of time travel has always been a popular subject in science fiction. It has captured our imaginations and fueled our curiosity for decades. However, it's not just a fantasy anymore. Recent findings have suggested that time travel may be possible, and the implications of this discovery are massive. To fully understand why Stephen Hawking was right, we must first understand the concept of time and how it works in the universe. The relativity theory, introduced by Albert Einstein over a century ago, revolutionized our understanding of time and space. It suggests that time is not a fixed entity, but instead, it is a relative concept that can be affected by gravity and motion. A team of scientists led by Norman Yao at the University of California, Berkeley, have discovered a new phenomenon known as a time crystal. The implications of this discovery are massive because time crystals challenge our understanding of time and its properties. They have been described as a new phase of matter different from solids, liquids, and gases. Time crystals have the potential to unlock the secrets of time travel and allow us to travel through time. Crystals, as most people know them, are physical and made of materials that have a regular and repeating pattern of atoms or molecules in space. For example, a salt crystal sodium and chlorine atoms are spaced at regular intervals. This gives crystals their distinctive shapes and properties. However, scientists created a new form of matter called a time crystal, which has a regular and repeating pattern of atoms or molecules in both space and time. Time crystals are very different from ordinary crystals. They do not stay still but constantly change their structure, like a pendulum that never stops swinging. They also do not lose energy or heat up, even though they are moving forever. This means they break the symmetry of time and defy the laws of thermodynamics. They are hopeful that time crystals can help us understand more about the nature of matter and the relationship between quantum mechanics and classical physics. Time crystals have not been found in nature, but they are created artificially by scientists in laboratories. They are very difficult to make and observe because they require very specific conditions of temperature, pressure, magnetic fields, and quantum manipulation. One possible way to create a space-time crystal is to trap a cloud of ions in a circular electromagnetic field and make them rotate at a constant frequency 3. This would create a ring-shaped structure that would be unchanged by any shift in space or time. Scientists believe space-time crystals exist near black holes because black holes can warp both space and time with their strong gravity. A recent study proposed that by placing space and time on an equal footing, one can derive new equations that describe how matter behaves near black holes. These equations suggest that some forms of matter could form stable loops around black holes, which could be seen as time travel. Stephen Hawking was a renowned physicist who made many contributions to the science of black holes. One of his most famous theories was that black holes are not entirely black but emit a faint light known as Hawking radiation. This implies that black holes can eventually evaporate and disappear. Another theory that Hawking proposed was that the surface area of a black hole's event horizon, which is the boundary beyond which nothing can escape, should never shrink over time. This is known as Hawking's area theorem, and it has been recently confirmed by observing gravitational waves from merging black holes. Hawking also speculated about the possibility of time travel using black holes. He believed that time travel to the future is possible because time slows down near a strong gravitational field like a black hole. This is called time dilation, and it has been proven by GPS satellites that orbit Earth. By creating time crystals in a lab and examining their ability to transcend both space and time, it breathes new life into the theory of time travel using black holes. Another concept that has been explored in science fiction is wormholes. A wormhole is a hypothetical tunnel that connects two distant points in space-time. Wormholes are a possible solution to Einstein's equations of general relativity, but they have not been observed or detected yet. However, scientists have been working on the concept of wormholes and have suggested that it may be possible to create a wormhole by manipulating the fabric of space-time. If successful, wormholes could be used to travel through time and space, making interstellar travel possible. Recent discoveries have suggested that it may be possible to travel through time, and the implications of this discovery are massive. Time crystals, wormholes, and black holes have the potential to unlock the secrets of time travel and allow us to explore the universe in ways that were once thought impossible. While we may not have the technology to travel through time yet, These discoveries are a significant step forward in our understanding of the universe and its mysteries. Stephen Hawking's contributions to physics have been invaluable in advancing our knowledge of the universe and the potential for time travel. As we continue to explore the mysteries of space and time, we may one day unlock the secrets of time travel. It will allow us to one day reach distant areas of our cosmos, explore other planets or faraway solar systems, and look for signs of alien civilizations. Thank you for joining us on this journey through the fascinating world of time travel and the legacy of Stephen Hawking. Until next time, keep exploring and stay curious. Let us know in the comments down below. As always, thanks for watching our video. See you in the next one.